guys wonder what is refrigeration system and how does appliance like fridge or aircon in our house work? In this video, we're going to discuss about refrigeration working principle, the transfer heat flow, coefficient of performance and the application. So, are you guys ready?
Refrigeration is a fundamental process that removes heat from a space to reduce its temperature. This technology is essential in daily life, preserving food in refrigerators, providing comfort cooling in air conditioning system, and supporting critical industrial processes worldwide.
Next, I will explain about the transfer heat flow. To begin with, heat moves from low temperature to high temperature regions. In refrigeration, system forces heat to make out of the cold space and release it to surroundings. This process helps keep the inside area cool. Then, to move out of the cold space, the refrigeration system needs energy. This energy usually comes from electricity. The electrical power runs the compressor, which compresses the refrigerant and allow it to circulate through the system. This process enables the refrigerant to absorb heat from the cold space and carry it away. Refrigeration works in a continuous cycle. The refrigerant repeatedly flows through the main components such as the compressor, condenser, expansion valve, and evaporator. As the cycle keeps repeating, heat is continuously removed from the space, maintaining a cooling effect. To sum up, refrigeration transfers heat by using energy to move heat from a low temperature area to a higher temperature area. The cycle runs continuously so that the cooling effect can be maintained.
Ever wonder how your fridge works its magic? It's not just cold air, it's a brilliant dance of physics called the refrigeration cycle. It all starts with a special fluid called a refrigerant. Its superpower, changing from a gas to liquid and back again, absorbing and releasing heat. The compressor squeezes the refrigerant, making it hot and under high pressure. Think of it as a revving up the heat energy. The hot gas flows to the condenser coils, where it's released all the stored heat outside the fridge, cooling down and turning into a liquid. Then it's through the expansion valve. This tiny hole causes a sudden drop in pressure, and the liquid instantly boils back into the cold gas. It flows through the evaporator inside the fridge, soaking up all the heat from your food and drinks, making everything nice and cool. And the cycle repeats. Modern fridges do this incredibly efficiently, keeping this cool with advanced control and eco-friendly coolants.
Coefficient of performance, or COP, in mathematical terms, the coefficient of performance in the output energy divided by input energy.
Before we understand why coefficient of performance, which is COP, can exceed 1, we need to understand how refrigeration system works. Unlike many machines that produce energy, refrigeration system mainly transfer heat from one place to another. Because of this special process, the efficiency of refrigeration system can be higher than 1. In a refrigeration system, the refrigerator does not create new cooling energy. Instead, it transfers heat that already exists from one place to another. The refrigerant absorbs heat from cold space, such as inside a refrigerator or air-conditioned room, and then release that heat to the surroundings. Because it only moves heat rather than producing it, a large amount of heat can be transferred. The refrigeration system only requires a small amount of mechanical work, usually supplied by electricity, to run the compressor. Even though the energy input is relatively small, it can move a much larger amount of heat energy from the cold space to the outside environment. Because refrigeration system transfer heat instead of generating heat, they can achieve a coefficient of performance COP greater than 1. This means the amount of heat removed from cold space is greater than the energy used to operate the system. Therefore, refrigeration systems are considered highly efficient compared to many other machines.
Ever wonder how your fridge cools food by moving heat against its natural flow? It's a masterpiece of energy management. It all started with a closed tube and a special fluid called refrigerant, which changes state to transfer heat efficiently. The compressor is the heart of the system, using energy to compress the refrigerant, raising its temperature and pressure. This hot gas then flows to the condenser, where it releases its stored heat to the outside and turns back into a liquid. Next, it passes through the expansion valve, which rapidly reduces its pressure, causing it to cool significantly. Inside the evaporator, this cold mixture absorbs heat from the fridge's interior, vaporizing it back into a gas and creating a cooling effect. And the cycle repeats continuously, moving heat to keep your food fresh. This advanced technology ensures efficient, reliable, and environmentally friendly operation.